Thank you so much. Bonjour tout le monde. Je suis vraiment contente d'être ici aujourd'hui pour vous parler. So I'm going to talk about some of the other parts of our research ecosystem that are enabled and augmented by having access to sovereign launch. But I am not necessarily the most elegant speaker about that. I'm going to give that opportunity to some of our students. Let me see if this advances. I bet you know what day this was.
I literally had goosebumps in my hands. It was so surreal. I knew that this was going to happen, but then to actually see it, it just hit me that, you know what, humans are actually going back to the moon. And I wasn't there for the polar era, but I'm here for the continents part, which is so exciting.
There was a part of me that was not really truly convinced this was actually about to happen after waiting for so long. So when those rockets lit off, I just felt a shudder of excitement. It was so cool that this is actually happening. We're going back to the moon.
Jeremy is a friend of a lot of people here in the Western Space Institute, and it's very exciting for everyone to know something going on. It makes it that much more personal. A little bit more scary when you're watching the vlog. I'm an age, so I remember those launches that didn't go so well, so it's really, really important, I think, to be here today and see everything go on. To be in a room with this many people was, just very surreal, and it certainly made it even more exciting. So I think there was a big sigh of relief at the end because everything went off really, really well, and they're excited to see him out there, and I'm sure to hear the stories when he comes home.
When I was a kid, I was inspired by astronauts like Julie Payette, Davy St. John, Chris Hadfield, and others who were Canadians who had made it all the way up to the International Space Station, showing that that is something a Canadian can do. I can only imagine what it's going to mean for kids today to see that there's a Canadian going all the way to the moon and back.
Someone from London can actually go to the moon. It makes me feel like space is so accessible for everyone, and if you actually work towards it and do your thing, you can actually go to space.
Let's do this more often. I love rocket launches.
So as Jack said, let's do this more often. I love rocket launches. But rocket launches are part of a full ecosystem, and this, of course, is sort of the pinnacle, sending a Canadian to the moon. But you could hear from what those students said how meaningful it is to them to see that people that they have met, that they know, have participated in this great experiment, in this great undertaking. And that is incredibly impactful and motivating, and it is a way of taking what we're doing in this room, which is very technical. We're talking about regulatory frameworks and building SMEs and all of these technical pieces, but then it has a huge amount of meaning for students, for the average Canadian, in terms of adding value and importance and excitement to what they're looking forward to. So I want to talk about some of the different ways that we're intersecting with this overall space sector. And one of the main ones that we're working on in Western is the CubeSat program funded by the Canadian Space Agency. So how many people in this room participated in a CubeSat? I only saw, we got a couple. This is an absolute engine. It's this amazing program that is funded by the Canadian Space Agency, and it gives start to finish mission experience for the next generation of space professionals. They take things from conception to design, build, testing, integration, launch, of course, and then also operations and science. And on the right-hand side in this panel right here, you can see that's a mock-up, a 3D printout of the Western Skylark CubeSat. Its primary science mission is to enable animal tracking, global animal tracking. But we also have some free real estate on our 3U CubeSat. And there are also 2 technology demonstrators that are in the second and the third U of the CubeSat. So we are able not only to have a very impactful science program, but we're also, with our free real estate, are able to have the capability to advance the technical readiness level of some important technology components. Specifically, we're working on photonic chips as well as filter wheels for optical and infrared cameras. Now, we have a strategic goal at Western Space to launch one science payload per year. And that is being enabled primarily through our CubeSat program. Our principal investigator, Jayshree Sabaranathan, is an amazing, amazing engineer, as well as a talent developer. You can see the CubeSat team on the lower right. That's right after they had their successful critical design review for the CubeSat program. These are interdisciplinary teams where the students are seeing the full mission life cycle. And I can tell you that our students get snapped up after they come and they have this kind of experience, not only by Canadian companies, but companies internationally. And I can tell you that we would really love to launch our CubeSats from Canada. Right now, there are CubeSat teams whose launches have been delayed because they do not have access and they are considered low priority. And so they're being shunted off to later missions. So having the ability in Canada to launch our own CubeSats would be absolutely game-changing and would really support this really wonderful system and program in an important way. We also are using CubeSats to attract the generation after the generation that is currently being trained. So you can see on the left, these are is our team, and these are pictures from the Girls in Aviation event that happens every year in London. London, Ontario is being developed as an aerospace hub, and that it is integrating training from the high school level through university level. There's a test pilot school there, and the airport is very active and engaged in developing this hub. And part of what we need, if we're going to get enough pilots, is we need to attract all of the people into the aviation industry. And so this is an important event. And I can tell you that those CubeSats and our access to space is something that is incredibly interesting and motivating for these young kids who are thinking about pursuing these careers. Launch is also a part of an ecosystem of technology development that includes things like stratospheric balloons. So the Stratos program out of Timmins, Ontario is a very important technology development program. Currently we are developing a space astronomy mission called POET to look for Earth-like worlds around nearby stars. And one of the steps on that technology development is to have a stratospheric balloon flight. So there's a picture right there from the Stratos program our team went on last summer. Their payload actually wound up in a lake. These things happen, as we've mentioned. Space is hard, and it doesn't always work out. But they picked themselves back up, and they're planning another flight next year. But this is an important component of this overall research landscape. Not only getting things into space, but also having the bits along the way, having the testing that we can get from Triumph for radiation, having the thermal vac capabilities, having access to stratospheric balloons. These are all pieces of the ecosystem that need to be in place in order for us to have a robust and active program. And this also provides a huge opportunities for students as well to get this mission experience by participating in a stratospheric balloon launch. So I have this question posed at the top of the slide. What do landfills have to do with Mars? And I'm sure someone can think of something very clever, but I'm going to give you our story, our version. So it turns out landfills are a source of methane, which is a very strong greenhouse gas. And there's a lot of reason where you want to know how much methane is coming out of your landfill. And it's also the case that it's unclear if there's methane in the atmosphere in Mars, and that's something that is of interest to planetary scientists. And so you can have the development of technologies for monitoring methane in our landfills that can also be applied for looking for methane in the atmospheres of Mars. And when we have an integrated ecosystem of research, then we can share these technology developments. We can attack a lot of science problems and make a huge amount of progress. And so trying to measure methane from a landfill can give you the tools so that then you can also hope to go and look for methane in the atmosphere of Mars. Brigadier General Horner talked about being able to be observationally independent when we're looking at space. And this is something that we've been developing at Western, and it came out of a science program to look for meteors. There is an international network called the Global Meteor Network. It has cameras looking up at the sky, and they're looking for bright streaks that go across the sky, and then they can triangulate them and figure out where they came from in the solar system and maybe go out and look for meteorites. But it turns out that basic technology of cameras as well as the software can also be used to track satellites as well as space debris and can give you a very comprehensive view of and access to space situational awareness. So that initial technology development, which was for looking for meteors, was expanded into Project Lucille, which is used to track satellites. And this type of capability can mean that we can be observationally independent as well. These technologies can also be used to provide support, launch support, in terms of tracking objects as well. So this is part of the research ecosystem, which again, if we're integrated, as the previous speaker said, we can share this knowledge and apply it to make sure that we're able to realize our goals. This technology can also be used to track contrails from airplanes, and it turns out contrails contribute approximately 2% to global warming. So being able to figure out where and when those contrails form can help figure out how to not form them so that you can reduce the impact of aviation and global warming. So I'm giving you a bunch of little snippets in order to give you an idea of how integrated the research activity can be to what you want to achieve. And so the sovereign space launch is really essential. I can tell you that everybody, all of our CubeSat teams, all of our researchers, when that announcement came out, we were absolutely ecstatic, absolutely thrilled. We want to launch our payloads from Canadian rockets, from Canadian soil, and to have our very talented people have an opportunity to stay here or come back, and we can actually do just amazing, exciting things. Thank you for your attention.